All right, we're back. We're on page 4 of Notes 1 of Calc AB. We're talking about derivatives. Now we're just playing around with our calculator to make sure we know how to do everything on there. So there's a lot of stuff you need to know how to do, and we're going to make sure you know how to do it. So your calculator can find the values of derivatives like at like nth degree derivatives, like 25th degree, 73rd degree, whatever. There's a template and we use it. It can also graph derivatives. The most useful graphs are going to be the first derivative and the second derivative. The most useful by far is the first derivative, but you'll also sometimes look at the second derivative. So for the first question we're going to do here, it says use a calculator to graph and find the zeros of f prime of x, the derivative of f of x equals blah. Make sure to pay attention to how we show our work here. So this is key. And this, I'm going to show the work right now. So the work that you're going to show when you're allowed to use a calculator to find the zeros of f prime is the following. F prime of x equals 0, and then an arrow, and then you're just going to write down the x values. So that's the work. Now we're going to go to the calculator. Let the calculator do the bulk of this. So we need to switch over. I'm going to start a new document in the hopes that it, I don't know, somehow works better. We want to graph the derivatives. So there's a couple of things here. One is I think that the best thing to do, which you don't have to agree with me on this, and you don't actually have to do what I'm going to do. So this, I'm going to define the function minus 5x and then minus 6. I think the best thing to do is to find the derivative. So I'm going to use the calculator, find the derivative. So template with respect to x of f of x, get an answer. Now I'm going to store this as, usually I just store it as fp for f prime of x. Sometimes I store it as df. And the reason I store it as df is it's df dx is the other notation for the derivative. So df, and then you'd have dg. I think that, I don't know, neither notation is great. It doesn't really matter. Just be consistent in your mind. Like, what are you going to do? Have a plan and execute it so you don't have to like think about what you're going to do, because thinking is the worst, right? So I'm going to do this. Now, why would I do this? I don't have an example on hand, and it's possible that they've actually like fixed this. It used to be the case that sometimes, so I want to graph fp, f prime, the first derivative. It used to be the case that sometimes when you would graph the derivative and you tried to find the zeros of the derivative, the calculator just wouldn't give you the coordinates. And that was super annoying. And the way around that is to, on the calculator page, find the derivative, store that, and graph that. That's like, that scenario never fails to work. Sometimes when you just graph the derivative, like we could have just like in F1, we could have just done this. And you know, you get the same thing. The question is, will the calculator give you the zeros when you do that? And I'm not 100% sure. So I'm gonna undo that. Now, when we want to find the zeros of something, the easiest thing to do is to press tab, also graph y equals 0. Then what I'm gonna do is menu, 8, 1, and then it's 3 if you have an original CX and 4 if you have a CX2. So that's fun. Click and then click, and you can see the zeros. And what I'm going to do is I'm going to write them down to 3 decimal places on paper right now. So I'm going to say x is approximately, paper on the iPad, I'm going to write them down, negative 2.633. Oh, how many decimal places was that? 3 decimal places, always. So it's possible that you're not seeing that many decimal places. And give me a second. 0.633. That's it. That's how we do it, right? If you're not seeing enough decimal places on the graph page, press menu, go to option 9. So graphs have their own settings page, which is kind of annoying. Change your display digits to float 6. I use float 6 all the time. It's enough for every question that you're going to do in my notes, and I think just every question you'll run into. You don't have to change anything else, but press OK. And if it asks you to, make that your default so that it will be the same in every new document that you create. So actually, maybe if I do menu 9, I'm going to change it to like float 5 for a second. Oh, it doesn't ask. Okay, so I don't know. If it asks you to, try to make it the default. Am I missing something where it's like, should I make this the default for everything? Nope. All right, well, I'm just gonna press OK. So I get all of those. Now, we're not talking about it exactly right now, but what does the derivative tell us? It tells us slope. If a function is increasing, it has a positive slope, and the derivative tells us slope. So anywhere this graph is above the x-axis, the original function will be increasing. Anywhere this graph is below the x-axis, the original function will be decreasing. So what I'm going to do is I'm going to change the window a little bit. And then, well, actually, I'm going to graph f of x and see just how it like fits. It doesn't fit perfectly. So what I'm going to do is menu 4, I'm going to zoom out. So zoom out, like choose the center right around the origin. That's pretty good. And then I'm going to zoom box, menu 4, option 2 is box. And you just go, like I always go top left corner to bottom right. It doesn't matter. You just have to do diagonals. And we get this. Okay, so the blue function here is the derivative. Everywhere the derivative is positive, meaning above the x-axis, the original function is increasing. You can see it, right? This function increases from like wherever until we get to like this point, which is a relative maximum. There's a relative maximum where the derivative is changing from positive to negative. These are connections that we need to make. When the derivative, the blue function, is negative, the original function is decreasing. So we're going to go from this maximum. We're going to keep decreasing until we get to a minimum. At this minimum, the derivative is changing from negative to positive. That's a thing. When the derivative changes from positive to negative, the function changes increasing to decreasing. The function has a maximum. When the derivative changes from negative to positive, the function changes from decreasing to increasing. The function has a minimum. And then after this minimum at 0.633, that's the x-coordinate of the minimum, the derivative is positive, the original function is increasing. These are connections that you need to make. And we're going to talk about them a lot. Like there's a whole set of notes that's really devoted to talking about that, but like start getting your brain thinking like that. And it will help you in the long run. So I'm going to go back to the notes and see what the next question is, because I think we answered that question. All right. And so you can see this is my work. How many decimals? 3 decimals. Note, 3 decimals. And then the other thing we did was float 6. So that's menu 9, float 6. Make it your default if it asks. I don't know why it's not asking. I guess maybe it's always defaulting to whatever you change that to these days. Use your calculator to graph the derivative of this. Find the x-coordinates of all points on the graph of y equals f of x at which the slope is 3. Okay, so this is a different question. I like it. This seems good. So I'm going to write down what I think the work for this will look like. So, and it's going to be weird. So it's just f prime of x equals 3. That's my work. And then I need to, I need to solve it. But to solve it, I definitely need a calculator. There's no way I'm doing this by hand. I think no matter what, I'm not going to be able to do that by hand. Like, with everything that I know, I won't be able to find where this derivative equals 3. But the calculator will. I'm going to insert a new problem. So doc for problem. So if you are not super into using your calculator, you're probably not familiar with a lot of these things. By starting a new problem, the var key is empty. See how it just says none? There's nothing in the var key. But if I go back here and I press the var key, there are things. And that's good because it means that I can like do a problem, be done with it, think I'm done with it, start a new problem on my calculator, do that. And then when we go over it, if I find out I was wrong on the first problem, I don't have to redo everything. It's still there, right? So use the calculator the way it should be used. So I'm just going to go straight to the derivative. Derivative of 3x squared plus x plus cosine of 6x. Now, your calculator has a different settings page. And on that settings page is where you will change degrees and radians also for the graph. So if you go menu 9, you can see the graphing angle, radians, always. That's the only way calculus works. So this is the graph of the derivative. And the problem I'm trying to solve is when is the derivative equal to 3? So to do that, I'm just going to graph 3 and see where these intersect. What I probably want to do, I probably want to put a box around this because like I don't know, like 90% of this window is useless right now. Here we go. That's good. Now I'm going to find these intersections. menu 814 for intersection points. The advantage here is it gives you all of them at once. The disadvantage is that it clumps them on top of each other. So to move them, what I think you do is you arrow over them and then you control click and drag. And here, I'm gonna drag it here, and then here, I'll drag here, and then here, I will drag here, and then why are there so many? One, two, oh, there are 5. Geez, I counted that wrong. I thought there were only 4. All right, so I have to write these down to 3 decimal places. So typically, if you are a considerate sort of person, you will try to write them in order from smallest to largest, which is greatly appreciated by everyone who ever needs to look at your work. And you want to endear yourself to people like that. I mean, you know, teachers are people, and graders are definitely people that you want to try to impress. So what I'm doing right now is on the iPad, I'm filling this in, and I'll like try to go back to it at the end and show you. But I'm just doing this at 3 decimal places. None of them round kind of strangely, so it should be good. I just made a bizarre looking 9 though. You'll never know, but it was weird. There are so many of them. 1.234, then x is approximately 1.327. 1.327. Okay, so I think those are all the places at which the slope is 3. So what I want to kind of do, I think I would like to, I'm gonna do something a little weird. So you need to know how to store values from here. So I'm just gonna show you right now, right? So arrow over it. I can't do this on the emulator because it won't let me, but what you're gonna do is press the control button and then the menu button while you're arrowed over it. Press control menu and choose store. And I'm gonna call this X1. And then I'm gonna do the same thing, control menu, store X2. Control menu, store X3, control menu. So what I'm trying to do here is I'm gonna graph all the lines. I'm gonna try. Control menu, and then X5. Okay, so there's 5 of them, so that's great. So what I'm gonna do is I'm gonna insert another graph page, same problem, right? So now it says 2.2 at the top. I'm gonna graph the original function, which I never, okay. Whenever you get down to 99, if you just like hit escape and then hit tab again, it'll like take you back. The original function is 3x squared plus x plus cosine of 6x. So I don't know that I can get a good picture of this. This doesn't look terrible. I'm gonna box around it. So I know all the values are between -1 and like 2. So let's see. All right, so what I'm gonna try to do, I have no idea. It looks like there should there be this many? I don't know, let's find out. So it's going to, I know the slope is gonna be 3. So all I really need to do is f of x1, oh, f1. So f3 is where I have the original. So f3 of x1, and then the slope should be 3, and then x minus x1. Okay, so that could be right. Sure, slope of 3, why not? And then I'm going to repeat that and do f of f1, f3, man, of x2, and then the slope should be 3, and then x minus x2. Okay, and then I'm just gonna, I mean, I don't know what the utility of this is other than like pointing out that you can do it, but you can do it. And so maybe you should, right? You should learn how to do things that you should know how to do. I'm like, where are x4 and x5? Oh, they're like way up maybe? f3 of x4 plus 3, and then x minus x4. I gotta change my window again. And then f3 of x5 plus 3, x minus x5. All right, let me change my window. My y values are like way off. So maybe just zoom out. Let's try. Zoom out. Oh, look at that. Zoom out. Let me box around this. There are like a lot of key points that I managed to miss by doing what I did. The y values were just like way bigger than I expected. All right, so if you look at the points of tangency, like here, follow this one, point of tangency there, follow. This is not 5 lines. 1, 2, 3. So what did I skip? Not that it matters. That's 5. 1, 2, 3. Did I do 4 or did I just skip it? 4. Oh, 4? Are 2 of these like basically the same? 1, 2, 3, 4, 5. 4 and 5. 4 and 5. 4 and 5 are like almost identical. Like you can't really tell. Can we tell the difference? Let's try to box around it. These are the kinds of things. This is how I learn a lot of math. Is I just basically keep exploring, like all the time. I recommend. Oh, so close. There we go. Sort of. There, you can almost make it out. It's like I don't think I can zoom enough to like get a really good picture of this, but wow, there's just this tiny little like deviation in the curve that goes through there. Oh, that's pretty cool. I think that's cool. I don't know. I won't speak for everybody. But anyway, let me go back to the notes, show you what I've written down, and then this video is clearly done because we are done with this page. And so calculator, I mean, it just like, it adds a little bit of time to everything that you do. So 3 decimals again, 3 decimals always, 3 decimals for life. We write them down preferably in ascending order from smallest to biggest, you know, but like sometimes you're gonna mess that up and that's okay as long as you try, but please try. So that's the end of this page. We'll be back in the next video to do more. So I hope you are finding these helpful.